Okay, so today we're going to talk about the second fundamental theorem of calculus. If you remember, the first fundamental theorem of calculus said that the integral from a to b of f of x dx is equal to the antiderivative of b minus the antiderivative of a. Okay, so that's the first fundamental theorem of calculus. It basically tells us how to do an integral. The second fundamental theorem of calculus tells us what we can do whenever we have a function inside the boundary of the integral. Okay, so in this case, we are going to use the first fundamental theorem of calculus to prove the second. So given the function f of t below, use f of x is equal to the integral from 1 to x of f of t dt to find f of x and f prime in terms of x. Okay, so if f of x is equal to the integral of f of t, and we need to find f of x, then we need to integrate from 1, actually let me So f of x, capital F of x, is equal to the integral from 1 to x of f of t. Well, my f of t is this guy, so 4t minus t squared, there we go, dt. So if we use the first fundamental theorem of calculus to find this antiderivative, the antiderivative of 4t is 4t squared divided by 2 minus t cubed divided by 3, evaluated from 1 to x. So that turns into 2t squared minus 1/3 t cubed, evaluated from 1 to x. Okay, and if we plug in these values here, we get 2x squared minus 1/3 x cubed. So that's the first part, minus, and then if we plug in 1, okay, so that gives us 2x squared minus 1/3 x cubed minus, and then if you evaluate this guy, you do get 5/3. Okay, so this is capital F of x. Okay, we also want to find f prime, so we have to take the derivative. Well, f prime of x is equal to 4x minus x squared. And if you notice, this is similar to what we started with. We've just switched out the variables. Okay, so if we look at number 2, now our function is cosine. So to find f of x, capital F of x, it is the integral from 1 to x of cosine t dt. So if you integrate cosine, you do get sine. So we have sine of t evaluated from 1 to x. If you plug that in, you get sine of x minus sine of 1. Okay, put that in parentheses, which if you're in radians on your calculator and you plug in sine of 1, so we have sine of x minus, and it turns out to be 0.841. Okay, so this is capital F of x. To find the derivative, well, the derivative of sine is cosine, and the derivative of this constant is 0. Okay, so f prime, again, if you notice, it's very similar to what we started with, we just changed the variables. So now we're going to do the same thing, but now our f of x, our capital F of x, is from 1 to x squared. Okay, so to find capital F of x, you integrate from 1 to x squared, and we are going to be using t cubed dt. So if you integrate t cubed, you get t to the 4th over 4, evaluated from 1 to x squared. Plug that in. So this is the first part. This is the second part. Okay, so x squared to the 4th, you multiply those exponents, so you get x to the 8th over 4, minus, and then 1 to the 4th is 1, so you get 1/4. So this is capital F of x. The derivative would be 8x to the 7th over 4. Okay, so, and then you reduce that and you get 2x to the 7th. Okay, now this, in this case, this does not reflect back to our original function, or what we started with, our f of t. Okay, very, very different. But you're going to see how they connect here shortly. So let's do this again. Now f of t is 6 square root of t. So to get capital F of x, it's the integral from 1 to x squared of 6 square root of t dt. Okay, and if you remember your properties of integrals, whenever you have a constant, you can just kick it out. So this is the same as 6, the integral from 1 to x squared, and I'm going to go ahead and change the square root of t into t to the 1/2 dt. Okay, so we integrate this, and so the 6 is going to stay outside, and you get t to the 3/2 over 3/2, evaluated from 1 to x squared. Okay, well, if you keep change flip, so you would end up flipping over that fraction to have 6 times 2/3 t to the 3/2, evaluated from 1 to x squared. So 6 times 2/3, 6 times 2 is 12, divided by 3 is 4. Okay, and so now we can plug in. This one's a very kind of a long one. So we get 4 times x squared to the 3/2 minus 4 times 1 to the 3/2. Okay, so again, you multiply these exponents. So 2 times 3/2, well, that's just 3 because the 2's will cancel. So you have 4x to the 3rd minus, well, 1 to the 3/2, anything, 1 to any power is 1, so we just have minus 4. Okay, so this is capital F of x. Now to get f prime, we take the derivative, and you get 12x squared. Okay, so yes, it's kind of a weird process, but we are going to use this in order to prove the second fundamental theorem of calculus. So now the actual second fundamental theorem of calculus. So it says that if capital F of x is equal to the integral from a to g of x of f of t dt, where a is any constant then f prime of x is the same as f of g of x times g prime of x. This kind of looks like the chain rule, okay? Which is kind of essentially what the second fundamental theorem of calculus is you're kind of proving a chain rule. So that's the formal definition. So what we're going to do is we're going to use the information that we found from page 584, and we are going to apply the second fundamental theorem of calculus. Okay, so if we look at the first one, to find f of x, we integrated from 1 to x of this function here. From the previous page, we found that f prime of x was equal to 4x minus x squared. So what we're going to do is we're going to apply the second fundamental theorem of calculus and see that these two are going to be the same. So remember that the second fundamental theorem of calculus, it has to have this g of x up top. Okay. If it doesn't, we have to do some switching around. So to find f prime, the x here is our g of x, and this inside here, that is f. Okay, so to find f prime, we follow this pattern here, this guy right here. So f of g of x, so what we're going to do is we're going to plug in g of x into f. So we have 4x minus x squared times g prime. Well, over here, g prime of x is just 1. So this is all times 1. That means that f prime is 4x minus x squared. Okay? Which is in fact what we got from the previous page. So on the second one here, from the previous page, we found that f prime of x was cosine of x. So using the second fundamental theorem of calculus, again, my g of x is x, which means that g prime is 1. So to find f prime of x, we plug in g of x into our f, which is the cosine of t. So what we're doing is we're plugging in x in for t there. So we get, excuse me, cosine of x times g prime, which is 1. So f prime is just cosine of x, which again is what we got from the previous page. So it's very easy to see whenever your g of x is x. If it's not, it can get a little complicated. So the third one here, again from the previous page, we found that f prime was 2x to the 7th. Okay, so we have to follow the map of the second fundamental theorem of calculus. So this right here is our g of x, which means that g prime is 2x. Okay, so if this is our f, we are going to plug in the x squared in for t there. So to find f prime, it is x squared cubed times g prime, which is 2x. So if you have a power to a power, you multiply, so you get x to the 6th times 2x, which ends up being 2x to the 7th. Now, one thing to remember is to using the second fundamental theorem of calculus only works if you're trying to take the derivative of an integral, okay? Last but not least, from the previous page, we found that f prime of x is 12x squared. So we are going to prove that. Okay. So again, we can actually kick out this constant here. He's not really important. Okay. So the x squared is our g of x, which means that g prime is 2x. Okay, and this is the f. So f prime of x, you plug in your x squared into f, so you have the square root of x squared times g prime, which is 2x. Okay, we also have this 6 out here that we just got to kind of stick out in front. Okay, well the square root of x squared is just x, so I have 6x times 2x, which is 12x squared. Okay, so find the derivative of each of the following functions. So if you're asked to find a derivative of an integral, you have to use the second fundamental theorem of calculus. Okay, so our g of x is this 2x here, which means that g prime of x is equal to 2. So capital F prime of x, again, we have to follow the format of f of g of x times g prime of x. So f of g of x, so you're going to take this and you're going to plug it in for t. So that means that you would have 2 minus 2x squared. And then times g prime is times 2. So f prime, if you simplify it all out, you get 2 square root of 2 minus 4x squared. Okay? Now, if we look at the second one, g of x, you notice that this one looks a little different. Now your little g of x is on the bottom. That is not good. You need it to be on top, okay? So in order to switch those, if you remember your properties of integrals, it's negative, and then you can just switch them around. So e to the cosine t dt. Okay, so your g of x, the little g of x is x squared, which means that g prime is 2x. Okay, so you're going to plug in little g of x in for t. So to get capital G prime is e to the cosine x squared times g prime, which is 2x. Okay, and simplify that, rearrange, whatever you want to call it. That's what you get. Okay, last but not least, the integral from 0 to cosine of x. Again, this is your g of x. You will plug it in for t. Your g prime, well, the derivative of cosine is negative sine of x. So capital H prime of x is equal to cosine x squared times negative sine x. So this is, and you can throw the negative out front, that's fine as well. Negative cosine squared x sine of x. Okay, or vice versa, it doesn't matter, it's multiplication, so Okay, so that's how you do these, just very straightforward, kind of a drill and kill. Now comes kind of some application. So picture to the right is a graph of g of t, and the function f of x is defined to be f of x is equal to the integral from -4 to 2x of g of t. So number 1 says find the value of f of 0. So if we are plugging in 0 in for x, then it needs to go in for x everywhere. So my integral becomes from -4 to 0 of g of t dt. Okay, so from -4 to 0, we are looking at all this area here. Okay, and so using geometry, we can figure out that area. Let me erase this so I can write here. Okay, so the area of this triangle here, it is below the x-axis, therefore it is negative. So I have -1/2 base, which is 1, times height. Well, that's where the negative comes in, is right there. So the height is -1. So this right here is -1/2. Okay, if I split this up, this triangle here is +1/2. The area of this rectangle here is 2. And the area of this quarter circle, so it's 1/4 pi, and then my radius is 2 squared. So 2 squared is 4 times 1/4, they cancel, so this is just pi. So to find this integral here, I have -1/2 plus 1/2 plus 2 plus pi. These cancel out, so you just are left with 2 plus pi. That is the value of f of 0. Okay, it's a little weird, but that's how you do it. So if you wanted to find the value of f of 2, so you plug in 2 for x, so your integral now becomes from -4 to 4 of g of t dt. Okay, now we already found from -4 to 0, and because this function is even, it's just twice the integral from -4 to 0 of g of t dt. Okay, and what I mean by even is it's symmetric across the y-axis. Okay, so because we know what this integral is, it was 2 plus pi, our answer is 4 plus 2 pi. Okay, and again, you could actually do the geometry and figure that out for yourself, but if you know these properties, they're kind of shortcuts. Okay, so if we look at number 3, find the value of f prime of 1. So first, we need to find f prime of x. Okay, so, and then we can plug in 1. So to find the derivative of this integral, remember it is you plug in your g of x into your function. So I would have g of 2x times, and then the derivative of g of x would be 2. So this is f prime of x. So if we wanted to find f prime of 1, we just plug in 1. So I have 2 times g of 2. So this graph here is the graph of g of t. So g of 2 is right there. Well, that's 1. So this is 2 times 1, which is just 2. Okay. Number 4 says find the value of f prime of negative 2. So again, we know what f of x is, we just found it. It's 2 of g of 2x. So f prime of negative 2 is going to be 2 times g of negative 4. So if you look over here, g of negative 4 is right there, which is negative 1. So your answer is negative 2. So find the value of f double prime of 2. So if we have f of x, and we need to find f double prime of x. Okay, this is where chain rule happens. Okay, so you have this outer function here, this g, and you have the inner function, which is the 2x. Okay, the 2 out in front is just going to stay there. So if you remember chain rule, it is g prime of 2x, and then don't forget the derivative of the inside, which is 2. So f double prime is 4 g prime of 2x. So if you wanted to find f double prime of 2, it's 4 g prime of 4. Okay, now we're given the graph of g of t. Okay, if we want the prime, we're looking at the slope. Okay, so the slope at 4, so right here. We actually cannot take the derivative at that point. Well, because it's an endpoint. Okay, it's not continuous. It isn't, if you remember back at differentiability, the only way to take a derivative is if it's continuous, and this is not because it's an endpoint. So this actually does not exist because g prime of 4 is an endpoint. Okay, so based on what we just did here, try to complete the next page on your own. Okay, so pause the video, take a second, try and figure it out. So I hope that you tried this page on your own. If you got stuck, I'll walk through a few of these. I'm going to go very, very quickly because this video is already long. So if I want g of negative 6, I'm plugging negative 6 in for x. Okay, well, this should be raising some red flags because in the integral, the smaller number always goes on bottom. So we have to switch it around. We make it negative. Okay, and so if we actually find this integral using some geometry here, from negative 6 to negative 1, so this area right here ends up being 4. This area right here ends up being negative 1. And this ends up being 4. Or I'm sorry, negative 4, because it's below the x-axis. So if we take all of those and add them together, so I have 4 minus 1 minus 4. And remember, all of this is negative because of this. We switched around the boundaries there. You do get 1. Okay. To find g of 6, we plug in 6 for x. Okay. And so over here, we are looking from -1 to 6. So this area right here ends up being 6. This area right here, sorry, this is -6. Keep forgetting those negatives. That is -2, and this ends up being pi. Okay, so if you add all these together, you get -6 plus -2 plus pi, which is -8 plus pi. Okay. For number 3, find g prime of 6. So if I wanted g prime of x, I have to do the whole substitution thing. So it would end up being f of x times 1 because the derivative of x is 1. So if I plugged in 6, we're just looking at f of 6. Okay, and if you look over on the graph, f of 6, scooch it over here, f of 6 is right here, and it is 2. So find g prime of 2. So I know that I already found g prime. It's just f of x. So if I plug in 2, I'm looking at f of 2. So on the graph here, f of 2 is down here, and it is -2. Find g double prime. So if g prime of x is f of x, then that means that g double prime of x is f prime of x. Okay, times 1 because of the chain rule. Okay, there's an invisible 1 there. And so if we wanted g prime of 2, we would need f prime of 2. Okay, and if you look at the graph, we are looking at f prime of 2, which would be right here. We want the slope at that point. Again, is this function differentiable at that point? And it's not, because that's a cusp. Okay, so the derivative of f prime of 2 does not exist because there is a cusp at t equals 2. Okay. Number 6, find g double prime of 4, or -4. So g double prime is f prime. So we're looking at f prime of -4. So up here at -4, well, what's the slope of that line? So it looks like it's -2, so down 2 over 1. So this would be -2, and give a reason, because the slope at t equals -4 is -2. Okay, last but not least, I'm gonna, again, it's kind of drill and kill. I'm gonna fly through this one. The continuous function f is defined on the interval from -4 to 3. The graph consists of 2 quarter circles and 1 line segment, as shown in the figure above. Let g of x equal 1/2 x squared plus the integral from 0 to x of f of t dt. Find the value of g of 3. Okay. So g of 3, we are just going to plug in 3 for x. So 3 squared is 9. So I get 9 over 2 plus the integral from 0 to 3. So we're looking from here to here. Well, if you notice, this is an odd function on this interval. This area is going to cancel out this area. So it's actually 0. So my answer is just 9/2. Okay. Find the value of g of -4. Again, plug in -4 for x. And there should be some alarms going off with this integral. It's backwards, so we need to make it right. And I'm going to go ahead and do some math and simplify this a little bit more. -4 squared is 16 divided by 2 is 8 minus, because I need to switch these around. Okay, so from -4 to 0, so these are quarter circles. So the area of that guy is going to be 1/4 pi r squared, where your r is 1. So this is just, actually it's negative. So this is -1/4 pi. Up here, this is a much larger quarter circle, so it's 1/4 pi. My radius is 3. Okay, so I would have 9/4 pi. So if you add those together, you have 8 minus pi over 4 plus 9 pi over 4. Okay, because those are common denominators, you can simplify those fractions. So 9 pi minus pi is 8 pi divided by 4 is 2 pi. And I'm sorry, that should... Oh, I missed a negative. I was wondering why my answer was positive. There's a negative in there. So this guy right here should be minus. Okay. Find the value of g prime. So let's first find g prime of x. So we need to take the derivative of this, and we need to do this whole substitution thing. Okay. So the derivative of 1/2 x squared is just x plus f of x, and then times 1, because the derivative of x is 1. Okay, so if we wanted g prime of 3, I would have 3 plus f of 3. Well, on the graph here, f of 3 is -3, so I have 3 minus 3, which is 0. To find g double prime, we take the derivative of g prime, well, the derivative of x is 1, and then the derivative of f of x. So if we want g double prime of 2, I have 1 plus f prime of 2, and if you look at f prime of 2, what is the slope of that function? Well, it looks like it is negative, let's see here, 1, 2, 3, so I'd say it's -2. So I have 1 minus 2, which is -1. And so that's how you use the second fundamental theorem of calculus.